Hi, I'm just going to solve one of the problems from our sheet we did in class, the First Law Open Systems handout. For our First Law Open Systems, what we saw was that for boilers, for the most part, are going to be operating under the assumption of constant pressure. And what that means is that if we're trying to find the heat, heat is going to be related to the change in enthalpy of the fluid. Or else if we write that out differently, we could say the heat is equal to H2 minus H1. H2 being my final point and H1 being my starting point. So I can break these out so that I kind of look at them separately, and what I can say is that here's where I start. So I start with the idea that H1 is my enthalpy level. And if I look at where I start, what I'm starting at is some water at 20 degrees Celsius and 2000 kPa. Well, this is clearly in the liquid region. And so when I see it in the liquid region, what it's going to trigger me to think is that I have a fluid that, if it's in the liquid region, does not get impacted by pressure. So fluids are incompressible in the liquid state. And so when I think about where I'm going to find my values, I'm going to bring up my steam table here. I have two choices. One is to use my pressure-based steam table, saturated region. But what I want to use in this case is my saturated steam temperature table. So I come here and I look at 20 degrees and scroll across. What I see is my saturated liquid properties for a liquid at 20 degrees is going to be equivalent to 83.96. So my H1 value, 83.96, and those are kilojoules per kilogram. Oops, I'm missing an 8. 83.96. My ending point is going to be what I would consider to be my H2 value. And what that is if I look up at my question, 95% quality steam. What conditions though? Well, it's going to be still at that 2000 kilopascals. So assuming the constant process that happens while I'm heating is that the boiler retains its pressure as it's heating up colder water all the way up to steam. So if I go to my tables, I'm going to need to know a few things, because my H value in a mixture in the inside of the dome is going to be represented by the equation HF plus X times HFG. So I'm going to need to find a few things. So H2 is going to be equal to, I'm going to look up my 2000 kilopascals. Here we are. HF 908.79, so you can see it here. Saturated liquid at 2000 kPa. So H2 is 908.79 plus my X, which is 0.95, and that's going to be multiplied by my HFG value. So if I bring this back up, what I can see is in the same 2000, HFG is 1890.7. So 1890.7. So if I calculate that out, what I would find is that my H2 value is 2704.955 again, kilojoules kilojoules per kilogram. And that makes sense to me. If I go back to my table, it's mostly vapor, so it's pretty close to my vapor properties, but it hasn't gone over. So I think that sounds reasonable to me. So if I come back to my first equation, Q, the amount of heat that was absorbed, is going to be the difference in the energies. So 2704.955 minus 83.96. And what my Q ends up telling me is that the amount of heat that was absorbed, 2620.995 kilojoules per kilogram. If I look into the question, there's a couple ways I could represent heat. Heat could be specific, meaning on a per kilogram basis, so the small q. It also could be the total amount of heat, so incorporating the quantity of water that I have. So in that case, Q would be equal to little q times my mass, capital Q, the total would be 2620.995 times 200 kilograms, and put over here, would be equal to 524199 kilojoules. Okay. Or that guy. Okay, hope that helped.